Hello, Jimbo. It is me, your favorite teacher. Don't do it. Nobody likes your attitude like that. All right. It's a weird. Okay. Anyway. All right. So we're gonna look at 2.1, and it looks like you're doing 2 through 40 evens. All right. So a couple of things before we jump into this that you probably have already gone over with Mr. Coe, but just to make sure. First thing is you're doing graphing on the Cartesian plane. So that means that when you are graphing, every section is labeled, okay? So they start from the right to the left. So this is plane 1, 2, you go down here to 3 and 4. All right. Also, you're looking at coordinates. So you've got X and Y, right, as your coordinates for each place that you graph. But they also translate into a couple of different things. So you're going to see X and Y referred to as domain and range. And you might see it referred to as A, B, S, I, C, something like that, I think, and ordinate. Okay, hopefully not. I've never seen any teacher actually request these, but anyway, so you might also, you'll see them definitely X and Y referred to as domain and range. And what else? Oh, and then another big one for this is function and what a function is. Okay, so a function is where each x is used once. Okay, so that will be a function. So for instance, if I had 3, -1, 2, -1, and 5, -1. If I look at these coordinates and I'm thinking, okay, x, y, x, y, x, y. My x is 3, 2, and 5. So for this, each x is only used once. So this is a function. However, if I had 3, -1, 2, -1, and then 3, -2. Let's say I have this group of coordinates. What I now have, when I look at just my x's, I have 3, a 2, and another 3. So this is not a function. Again, so each x can only be used once. You can only have that number used once on your graph. And then it is a function. Okie dokie smoky. So let's jump into number 2. All right, these instructions say, again, you don't have to write any of this down though. I just kind of throwing them out there. Alrighty then. So graph each relation and state its domain and range. Okay, so I am just going to write these coordinates down. You don't have to, but I'm just going to have them here for myself. So we're dealing with -4, -1, 4, 0, 2, 2, -1, and 2, -3. All right, so first they want you to graph these. Now, unfortunately, I do not have any graph paper here at home, but hopefully you do. All right, so let's go ahead and start with the graphing. So if I'm looking, here's my x-axis and my y-axis here. All right, so my x's go from -1 to +2. So I'm just gonna do like this. And then my y's, I'm just kind of like estimating 3, 4, 1, 2, 3, 4. Okay, so I'm just going to kind of graph it out like this, and you just put yours where it's supposed to be. All right, so you know the drill with these. go in the elevator and then go up or down. So I've got -1 from 0. I go -1 to +4. Then I go 0 to 2. So if I'm here, I'm at 0. So if my x is 0, that means I don't get in the elevator, but I do go up to the +2. Next I have 2, -1. So I'm going to go over 2 and then go down to the -1. And then again, I have +2 and I go down to the -3. Okay, so your graph, it should just look something like this. Now we're not going to try to connect the dots, but we did graph it. The other part of what they wanted was for us to list the domain and the range. Now when we do this, it has to be in order, least to greatest. So here are my domains. I've got a -1, a 0, a 2, and a 2. All right, so basically I have -1, 0, 2. So I will write domain is equal to, now I do this fancy little squiggly, and I'm going to list them least to greatest. So I'll start with my negative number, -1, then 0, then +2. So I'll have -1, 0, 2, and close your fancy squiggle. All right, and then I need to list the range. So fancy squiggle again, r is equal to, here I'm looking at my y's. So I've got a 4, a 2, a -1, and a -3. So again, I'm going to list these least to greatest. I'm going to start with my -3, then -1, then I'm actually just working backwards here. -3, -1, 2, and 4. 2, 4, and I will close my fancy squiggle, and that is number 2. Don't forget that you can pause anytime you want, and make sure that you are not freaking out trying to keep up with me. All right, just pause and then copy. All right, so keep it even. So let's go to number 4. Okay, number 4. So here they are giving you a map, and it looks like this. Again, don't draw this. Okay, they're giving you 2 circles. So these are your X's and these are your Y's that you list. These will also be in order least to greatest. So they have given you -1, 0, 1. Over on the Y's, they have a 2 and a 4. All right, so when you're using these, what they'll give you is arrows. So they'll say -1 goes to 2. Okay, so for example, here I would go ahead and write these down so that you have them. But my first coordinate then is x, y, or -1, +2. All right. Next, they drew an arrow from 0 to 2. And then they draw an arrow from 0 to 4. And 1 to 4. Okay, so I'm just going to write these coordinates down. Now again, my job is to graph them and then to list the domain and range. So for number 4, I'm going to go ahead and I'm looking at my coordinates. So this is what I'm going to end up graphing. It looks like my y's need to go out to 4, so I'm going to go 1, 2, 3, 4. My biggest number is 4, so I'm just going to make sure I have at least 4 on each of these, but you are hopefully using graphing paper. All right, so let's go ahead and start by graphing them. So here I'm going to go over -1 and then up 1, 2. Okay, so -1, 1, 2. For my next one, I'm at 0. So remember, that's my x. I'm not going to go in the elevator, but I am going to go up to 2. Same thing for this third one. I'm at 0. It doesn't tell me to go left or right, but I do go up to 4. And then lastly, I'm at 0. I've got 1, 4. So I'm going to go up 1 over 1, and up 4. So that is what your graph should resemble, something like that. Okay. And then we need to list our domain and range like we did for number 2. So we'll say D is equal to fancy squiggly line. And again, I've got a -1, 0, 0, 1. So I'm going to list these least to greatest. If I have the same number, I'm only going to list it one time. But they're pretty much in order. So least to greatest will be -1, 0, and then 1. And close out fancy squiggly line. All right, so my range is all of my y's. So I've got a +2, +2, a 4, and a 4 like I had here. So I only have those 2, and I am just going to list them in that order. 2, 4. Oh yeah, sorry. I'm looking at these, but I can just take them from here too. So notice that this went here, right? And this went there. So you can pull them directly from there. And that's all you need for number 4. Right. Now let's keep going. So number 6, stay on those evens. Okay, so it wants you to write each relation as a set of ordered pairs and state whether it is a function. Okay, so for number 6, again, I'm writing, you don't have to write this part. Okay, I'm just going to show you the map that so they're saying that the x or the domain is -1 and 0. And then over here, the y's are 2 and 6. All right, and they have drawn lines just straight across like this. Okay, so again, the instructions say write each relation as a set of ordered pairs and then say if it's a function. So if I make an ordered pair out of these, again, remember that this is x and these are your y's. So we just have to write them. So this will be -1, 2. And then this one will be 0, 6. Okay, so there's the first part of your answer. And then it says, is it a function? Now again, remember that if it's a function, that means we only use x one time. So because -1 only has one arrow going to a y. 0 only has one arrow going to the y. Yes, it is a function. Now, if it looked like this. So if we went 0, 0 went to 2, and 0 went to 6, it would not be a function, okay? But this time, it doesn't do that. All right, let's jump over to number 8. And let's see. Okay, so they have given you a bunch of dots. So again, let me draw this. 1, 2, 3. Okay, it looks like the most we go over is 3. So I'm just gonna, okay, so you have this in your book. Do not draw it. All right, and I'm just gonna kind of mimic what it looks like. 2, 1. So I've got here that it's 1, 2, and then 1. This one is up 1, over 1. This one is just at the 1. This one is up to the 2. This one is here. Okay, so the problem in your book looks something like this. So again, what they want you to do is come up with the ordered pairs for these and then say if it's a function or not. So we just need to name each of these. So if I start over here on the left, I go over 1, 2, which is -2. And then I went down 1, which is -1. All right, same thing for this one. I start at 0. I went over 1 to the left, which was a -1, and then up 1, which is positive. On this side, I went over +1, and then I went nowhere for y. I didn't go up or down. I'm in the elevator, but I didn't go up or down, so I'm going to say that y is 0. For this one up here, I get in the elevator over 1 and up 1, 2. So that's going to be 1, 2. And that leaves this one. So again, from 0, I get in the elevator 1, 2, and then up 1. So that's 2, 1. Okay, so there are your ordered pairs. And now they want to know if it is a function. I just wanted to double check myself on these since I drew them in. 2, 2, 1. Okay, so again, I know if it's a function if I only have each x once, right? So I'm just, you don't have to do this, okay? But I'm just gonna, I've got a -2, I've got a -1, you don't have to write this. I'm just listing them. +1, +1, and a +2. So again, the rule for functions is that you only use an x one time. But the problem is, right here, I have two sets that have the same x. So this one will be no, it is not a function. Okay, because again, the x is repeated more than once. Again, you don't have to write that down. All right, let's keep going. Number 10. This one says draw a mapping diagram of each relation and state if it's a function. Okay, so for number 10, again, you don't have to write this. I'm just going to write these coordinates down. Okay, so they want the mapping diagram, and that is this. So you need to, you're going to do your 2 circles, okay? And inside of each of these, this is your x and your y, you're going to list your x's here, least to greatest, and then the y's here, least to greatest. So on my x's, I have a -1, a -1, and a -2. Okay. So if I list those least to greatest, I'm only going to put the -1 in twice, or once, right? And then my -2. For the y's, I've got 1, 2, and 2. So if I list that least to greatest, I'll just have a 1 and a 2. And then I am going to draw lines to connect them. So I've got a -1, +1. So I'm going to draw one line here and connect these two. On my second coordinate, I've got -1, 2. So I'm going to, from this same, I'm going to draw my line there. And then from the last, I've got a -2, +2. So I'm going to draw one line here. All right, and then they want you to tell them if it is a function. So the problem is, again, I can only use x one time. So I can see that right here, -1 goes to 2 different y's, or I could see that the x's are repeated here in the coordinates. So the answer to this, here's the first part of your answer, and then you will say no, it is not a function. All right, number 12. Alright, for number 12, again, we're doing the mapping diagram and we're stating if it's a function. So yours will look something like this in your book. I'm just going to go up. I'm just going to go 1 on each of these. Okay, so I've got 1 here, 1 here, and 1 here. Okay, so mapping diagram again, 2 circles. So here's my x. Here's my y. I'm going to go ahead and label those, but you don't have to. And for the sake of this, I'm going to go ahead and just label these coordinates. So over here, I will start with the left. I went over 1 and down 1, so that's 1. I'm sorry, -1, and then going down is another -1. This one right here in the middle, remember your X, you didn't get out of the elevator, so that's going to be a 2. Then you didn't go up or down either. So that's a 0, 0. And then the one on the right, you went over 1. It's a +1. And then up again 1. So we're going to call that one 1, 1. All right, so if I'm listing all of my X's, I've got a -1 here, a 0, and a +1. So in order least to greatest, looks like -1, 0, 1. For my Y's, I've got a -1, a 0, and a +1. Same thing, -1, 0, +1. Okay, so now we just need to connect them. So if I look again at my coordinates, -1, -1, I'm just going to draw the line there. 0 to 0, and 1 to 1. All right, that is your mapping diagram. And then the question is it a function? Again, if each X is only used once, it only connects once to each Y, then the answer is yes, it is a function. Okay? All right, bouncing over to number 14. Okay, so number 14 is a cool one you might like because it has a map. I'm going to show this to you for 1 second, but on a map, they're giving you longitude and latitude. Okay, so you don't have to write this, but I'm just going to show you longitude, latitude. Okay, so it looks kind of like this, right? And what you need to know about this is that longitude is your X and latitude is your Y, okay? The longitude goes across the map and the latitude goes up and down the map. So again, X-axis, Y-axis. So let's look at what this looks like. Get something to cover it. Okay, so here's the map that they're giving you, and what they want you to do is state which state that they're giving you coordinates for. So number 14 says longitude 80, latitude 40. So again, longitude is across at your x-axis. So longitude is 80, right? And latitude is 40. So I'm going to be here in between 85 and 90. And then I'm going to go down until here's 40. I'm going to go down until I hit 40. So I'm like right here. Oh wait, no, 80, 40. 80, 40. So I land right in here, which if Coach Cooper taught you anything, you will know is the great state of Pennsylvania. All right, so here we will write Pennsylvania. All right. And full disclosure, I had no idea. I had to look at the answer key. Okay, so that's 14. All right, and then that takes us to 16, so we're going to do that again. Let's look at the map one more time. Again, longitude is your X, latitude is your Y, and we're doing 120 and 45. So again, here's 120, here's my X, 120, and then I'm going to go down to 45. So I'm going to do 120 until I hit the first bar. So I'm in this little area right here. Whoops, didn't mean to draw on that. And that, my friend, is the great state of Oregon. Actually, it's really not a great state. They have a lot of issues, but okay. But I'm pretty sure it is legal to do assisted suicide there, which is kind of sad. All right, so that's number 16, longitude, latitude. Alrighty. So for number 18, they're going to give you some information, and then they want you to tell them on that Cartesian plane what plane you would be in. Okay, now just FYI, we talked about this at the very beginning, but as a refresher, here's your graph, and these are your planes: 1, 2, 3, and 4. All right, so number 18 says both coordinates are negative. So whatever it is, this would be a negative and this would be a negative, right? So we just kind of have to think, how would I graph this? I'm going to start at 0. If my x is negative, I'm getting in the elevator, right? If I'm going negative, I'm going over here to the left. Now, if my y is also negative, I'm going to go down, which puts me in plane number 3. All right? All right, number 20 says the x coordinate is negative, so I'm just going to kind of write this out, and the y coordinate is positive. All right, so same thing. I start over here at 0. If my x is negative, I'm moving over here to the left. If my y is positive, then I'm going to move up, and that puts us here in plane number 2. That's 20, 22. Says the ordinates are negative. The ordinates are negative. Now, if I have x, y, now I told you at the very beginning that there was another word for the x and the y, right? I'm kind of looking for this paper. Let me see. So, oh yeah, here it is. So it was like abazibakaga is the x, and the ordinate is the y. So if it says for 22 that the ordinates are negative, so I don't know anything here about the x, but I do know that the y is negative. So let me look up here. So if I'm here at 0, now if I could either go to the left or to the right on the y, or sorry, on the x, I don't know. But let's just think of it both ways. So if I'm here and the x is positive, I would come over here. Then it says the ordinate or the y is a negative. I would go down to 4, right? So definitely here. Now, because I don't know about my x, what if my x was also negative? I would go to the left. But if then my y is negative, I would come down, which puts me in plane number 3. Okay? Don't let them psych you out with all of this vocab. Just walk through it carefully. It will be fine. They're just trying to confuse you with all of these 1,000 names for everything. But that's okay. All right. So number 24 sucks. Okay. Yeah. Number 24 is a baddie. Hang on. Okay, so for number 24, again, they want you to state the domain and range and then say if it's a function. So this one looks really crazy, but where you really need to focus is where it touches the x or y axis, okay? So if I'm going to state what the domain is, right? There's my fancy squiggle. When I look at this graph, what I notice is that it is an arrow and it's just kind of going on till infinity. This one here is also meets at 0, 0, right? And it just goes on until infinity. So what I know is, as far as where it starts, is it starts right here on, here's my x, here's my y axis. It starts at 0, okay? So I'm going to start with that, and I'm going to go ahead and say that x is such that, right? So I'm trying to name everything that x could be, because if I keep going off here, I mean, I could make this a point, make this a point, make this a point. So I have to just kind of answer for anything that x could possibly be. And I know that it is at least 0, okay? It is at least 0. And then where I see it going off here in plane number 2, it's going from x, and then if this was any of my x, if I was saying, okay, I want to name this plot here, I would be over here like -3, positive, whatever, right? So my x would be negative. This one too, if I'm going to name this point right here, then I would come out here and I'd say -4, negative whatever. So x is not ever going to be anything bigger than 0, because if it was, I'd have arrows over here, right? This is the positive. This is 0, and this is just gets smaller and smaller. So I'm going to say that x is such that x is less than or equal to 0. Okay, so it includes 0, but it's never going to, this is the direction I'm going in, right? X is always going to be smaller. And close that out with a fancy squiggle. Now, for your R is going to look like this. You're going to do your little double line. It's like kind of like it has 2 backs, right? So I go 2 lines and then I make an R on it. And what this symbol means is all real numbers. All right, because if I look up here, if I'm in this coordinate, my x will be a negative, but my y could be a positive number. Same thing down here. Here's my x. It's definitely going to be 0 or a negative, but it could also be a negative for my y. So really, it could be any number. So this R tells me that it's like a full set of any real number. Any real number that exists, the range falls under that. Now, the last question that they want to know is this a function? Okay? And so the answer is a quick check. If we draw a vertical line anywhere in this graph, which you hopefully did not write, if I just draw a vertical line, does it touch? In multiple places? Well, sure it does. It touches here and here. It touches here and here. It touches here and here. And that means that your answer is no. It's not a function. Because if I connect at this point and this point, that means I have the same x. I just go up or I go down at a different place. Same thing here. Here's my x. I go up or down. And so I'm using that same x with 2 different y's. Here's my x, 2 different y's. So it's not a function. We're repeating those x's several times. All right, so 24. All right, let me go ahead, and 26 is going to look something like this. Again, don't draw this. All right, so here's my Cartesian plane. 1, 2, 3, 4. 2, 3, 4. So I'm like here at 4, right? And it does kind of stops here. All right, so it looks something like this. Okay, again, don't draw that. So they again want to know what the domain and what the range is. So this is another fun one that Mr. Code left you. Let's see. So we're going to do our domain. We're going to do our range. So it's going to look something like this. Okay. Now, when I look at my x, again, this, you'll notice there's an arrow here and there's an arrow here. So I need to be able to list like what my possible x's are. And the truth is they could be a whole lot of things, right? So when I am looking at my x's, so like if I go across here, and this just let's assume this goes on for infinity, this goes on for infinity. And I didn't draw it very well, but it kind of goes out this way really. So it's kind of like this wide arc that probably you would think of it coming out here, coming out over here. So x could be any number here to the negative, and then it comes out to the right. So actually for my domain, I'm going to go ahead and reuse that r. And I'm going to say that my domain, because of those arrows, could be any real number. I mean, it's just kind of going out like this. All right, I can't give a definite spot to it. For my range, what I'm going to look at is where it lands, okay? Where it lands here. And I can see that if I am listing my y, it's either going here to the negative, or it's coming here, all right? And it's going down, it's negative. So I know that my range is going to be either in the 0, right? In the zeros, or it's going to be some kind of negative number. So I am going to list this as y is such that y is less than 0. Now it didn't land here on 0, right? It's right here at -1. Are you with me? So when I say right here where it meets, here's 0, and here I'm 1 below it. So it's not equal to 0, but it is less than 0. So we'll close that out with a fancy squiggle. All right, so same thing here when I'm saying, okay, is this a function? And remember here we drew these vertical lines. So I'm going to do the same thing here. Again, you don't have this on your paper, but when I draw these vertical lines, does any of this graph connect like it did here? It sure doesn't. And so my answer is yes, this is a function. Alrighty. Okay, for number 28, to get rid of this, don't forget to pause if you need to write stuff down. Alright, for number 28, they're giving you a mathematical expression, and they are giving you possible answers for x. So what I'm going to do is I'm just going to go ahead and write this out as a t-chart. Now, the t-chart is not how they want you to answer, okay, but we will set it up so that it works. Okay, so let's look at this. So they're naming this g of x, okay? They're going to give you some possibilities of what x could be, and then they give you your expression, and then you're going to name what that is. So this number 28, okay, so it says that 4x minus 2 if x is equal to -9, 2, or 6. Okay, so we're going to come on down here. And then we will come down here. Okay. So this will be kind of like the y. So they're saying if I plug this in for my x, if x is equal to these numbers, then my y, or my range, will fall under this. Okay, so let's go ahead and we're going to plug in each of these numbers where the x goes. All right, so that will be 4 times -9 minus 2. All right, so let me see. Okay, so 4 times -9 is -36 minus 2, and that's going to equal 38. Okay, now what they want you to do is put this in function notation. That means that I'm going to put this -9 up here, so my answer will be g of -9 is equal to, and then we'll just put 38. 8. Okay, and that is answer number 1. Okay, so same thing here. If we're going to solve for g of 2, so I've got 4 times 2 instead of 4x minus 2 will be 8 minus 2, which is 6. So my official answer will be g of 2, right? I'm plugging the 2 in here, and that is equal to 6. G of 2 is equal to 6. And the last one is 6, so again, I'm going to put that 6 in for x. 4 times 6 minus 2. 4 times 6 is 24. Minus 2 is 22. So, function form says g of 6 was equal to 22. Okay, and these are your answers. Alrighty. Okay, that takes us to number 30. And, alright, we're going to do the same thing. Okay, so we're going to say we're solving for g of x. Okay, and our expression is x squared. Make sure that's right. Yeah, x squared plus 3x minus 9. And that's if x is equal to 4, negative 1, or negative 3. Okay. So this is like saying your y. All right, we're going to now plug that 4 in every time we see x. So this will be 4 squared plus 3 times 4 minus 9. All right. 4 squared is 16 plus 12 minus 9. And that is going to equal, so that's 28 minus 9 will be 19. So we're going to do the same thing. Our function notation would be g of 4. So I'm going to have g of 4 is equal to 19. That's my answer. All right, same thing here for negative 1. Now, remember, if you are substituting a negative number in for x, like we're doing here, I'm going to put it in a parentheses. Okay, so that'll be negative 1 squared plus 3 times negative 1 minus 9. Now, I'm bringing that up here because with your exponent, if your number is in a parentheses and it's a negative, it makes a big difference. If it's in the parentheses, what it ends up being, and you don't have to write this, is you actually keep it as a negative number. So you will show it as a negative number twice. So that will be a negative 1 times a negative 1, which is a positive 1. Plus 3 times negative 1 will be negative 3 minus 9. All right, so I've got a negative 3 and a negative 9. 9, 10, 11, 12. That's a negative 12 and a positive 1. So the negatives win. And we cancel it 1 out. So I'm going to write this as g of, instead of g of x, I'm going to say g of negative 1. And that's equal to negative 11. Last one, same thing. I will have this negative 3 here. Negative 3 squared plus 3 times negative 3 minus 9. All right, so this, because it's in the parentheses, will be like saying negative 3 times negative 3, which gives me a positive 9 plus a negative 9 minus 9. Okay, so you can look at this two ways. If I look at 9 plus negative 9, these two are actually going to cancel each other out. And that leaves me with negative 9. So I will write this as g of negative 3 is equal to negative 9. Okay? And those are your answers. All right, for number 32, they want you to graph your function. Okay, so 32. Okay, so on number 32, we're doing the same thing that we did up here, only what we're going to do is we're going to graph. We're going to show it what it looks like on a graph. But first we have to solve it. So you don't have to write this part. Okay, I'm just going to write it for myself. So I've got x of y is such that y is equal to negative 1/3 x plus 1. And okay, so there's y, and then they say that x is an inequality. So I've got negative 3 less than or equal to x less than or equal to 3. All right, so let's take this apart a little bit. This is our function. So if I'm looking at this, okay, so this will be, so when I'm naming my possible x's, let's put them over here. And I say y is equal to this equation, 1/3 x plus 1, and that's going to give me my y's. Okay? Yeah. All right, so let me say that again. So what I know is that y is equal to whatever this expression is, okay? Or this is an equation at this point. Here we go. So y is equal to whatever I get from here. Now, what I have to come up with is what are we plugging in for x? And this is the information they give you for x. They say that x is greater than or equal to negative 3, and that x is less than or equal to 3. So let's look at this first. If x is less than or equal to 3, it can't be any bigger than that, right? It's got to be 3 or nothing else. So I'm just going to kind of come down here and say, okay, I know that 3 is as big as it gets. Now, then it says that x is greater than or equal to negative 3. So again, you don't have to draw this, but let me just put this, here's a negative 3, here's a 3, and here's a 0. So if we were looking at how to graph this, this is what it would look like. So here's my positive 3, x is less than or equal to 3. So this would be closed, and it would be going in this direction, right? Now, if I look at this, I would write it x is greater than or equal to negative 3. I just flipped this around. So here's my negative 3, greater than or equal to. So this, again, would be closed. Greater than or equal to, so they would look like this. This is what we're dealing with. Again, you don't have to draw this. I'm just showing you another way to look at it. So it starts and ends with negative 3 and 3. It could be anything in between, is what this is telling me. Any of this falls in, but it starts here and it stops here. So what we're going to do is we're going to plug in these numbers just to show. I mean, we could pick any 3 numbers really, right? I'm just going to go with what we know. So I'm going to go least to greatest. Got negative 3, 0, 3. I'm going to plug those in as my possible x's, okay? And I'm just going to get some y's. So if we know this is the smallest and this is the largest, and this is like average in the middle, then we can see where y is smallest, where y is largest. All right. So I'm going to take these numbers and plug them in for x. So I've got negative 1/3 times negative 3 plus 1. All right. Now, if I have a fraction, remember I'm going to think of this as negative 3 over 1. And I can cancel these out basically. All right. A negative times a negative is going to be a positive. So this would end up being negative 3 over 3 or positive 1, right? So I can actually, so let me show you what I'm talking about here. So if I have negative 1/3 and I'm times negative 3, right? So I've got a negative times a negative. These actually will cancel each other out. Negative 1 divided by divided by 1. So I've got a negative 1 times a negative 1, and that equals a positive 1. So I end up with 1 plus 1 equals 2. And I'm just going to double check myself on this. 32, graph the function. Yes, positive 2. Okay, so when I graph, all right, my first coordinate then is going to be negative 3, 2. Okay, so I'm going to come over here and I'm going to go negative 3, positive 2. Okay, so you should have something like that. Again, this is negative 3, 2. Let me just label that for you, just in case. All right, so now we're going to do the same thing here. I'm going to take 0 for x and solve. So I'll have negative 1/3 times 0 plus 1. So anything times 0 is 0, and that leaves me with 1. So this will look like 0 on my x, right? I'm not going to go in or up out of the elevator, but I will go up 1. So this one will be 0, 1. Okay. Let me do this so we don't get confused. Here, this is your graph. All right. And then last but not least, I have negative 1/3 times 3 plus 1. So this is going to be the same thing that we had here. We had negative 1/3 times positive 3, and I'll just say over 1, right? Which ends up being a negative times a positive, negative, so that's a negative 3 over 3 if I march straight across. And that will give me a negative 1 plus 1 here. And those cancel out, and I end up with 0. So this one ends up being 3, 0. This is my coordinate. So again, I'm going to come over 1, 2, 3. I'm going to go 1, 2, 3, and I'm going to stop right here because I have a 0 for my y, and that will be 3, 0. I'm just going to double check. Yes, so we will close this out. Here's a point, and we'll just draw a line through that graph, and that is your answer. Okay? You don't even need this, really. You just needed these two. But that's how it would show up. All right. Number 34. Okay. Whew, same thing. All right, so you can see on yours what that looks like. There's a whole lot of x options. So I'm just going to come over here and I'm going to say these are all our x's. Okay, and we get through all, once we plug it into this, we get our y. So I've got f of x. Oh, so they're giving us an absolute value of 4 minus x. And x is equal to negative 1, 0, 3, 4, 6. Okay, so as a reminder, when we're looking at absolute value of anything, what happens in here? It does not come out as a positive or as a negative number. If a negative goes in, it doesn't matter. You solve it, it comes out positive because all it tells us is how far a number is from 0. So it could be here, it could be here. It doesn't matter. It's how many hops it is from 0. this is 1, 2 places from 0. This is 1, 2 places to 0. It doesn't matter. It only comes out positive when you're dealing with the absolute value. The absolute value is about distance to or from 0. Doesn't matter if it's positive or negative. So we will just stick these numbers in to our absolute value expression here and just write our answers. So this ends up being 4 minus negative 1. So if I have two negatives, I can make them a positive, and 4 plus 1 is 5. So we're going to have negative 1, 5 as our first coordinate. Same thing here for 0. So if I have 4 minus x, or 0, 4 take away nothing is still 4. So this next coordinate will be 0, 4. X, y. Here's 3. So I've got 4 minus 3 is 1. This coordinate will be 3, 1. 4 minus 4 is 0. This coordinate will be 4, 0. So again, I'm just taking my x and the answer I get from my y, and that makes my coordinate. This will be 4 minus 6. Now remember, this again is absolute value. So it equals negative 2. However, we don't do negatives. So it equals 2, and my point here is 6, 2. No negatives. Alrighty. Now the only reason, just to bring it up, that this is negative up here is again that it was the x. So it was already given to us. These are set. They're set. You don't change them. The only thing we're solving for was the y. So if the x was negative, it's okay. It can stay negative. But the y cannot be because it's part of the absolute value. All right, so you will need to graph this. And 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my biggest number is 6, so I'm just going to, 2, 3, 4, 5, 6 as I'm drawing this out. But hopefully you have some graph paper. If not, that's cool. Just do it the way I'm doing it. So I'm just going to take all of these coordinates and plug them in. So 0, I go negative 1, up 1, 2, 3, 4, 5. Then I'm at 0, and I go up 1, 2, 3, 4. So I'm just, you know how to chart these. I'm going to put them in. I'm going to go 3, 1, 4, 0, and 6, 2. So your graph should look something like this. Okay. All right, so that will be your answer there for 34 and 36. State the independent variable, state the dependent variable. Okay, so for number 36, I guess that's something else I should have brought up at the beginning. So when it asks you for the independent variable, that should be what doesn't change. And usually that is going to stand for x. So if, you don't write this down, but what you're looking at is h of r is equal to 5r minus 20. Okay, so if I'm looking at this statement and I'm looking for the independent variable, the one that could possibly change, every time we came up here and did any of these, it changed, right? If you look at how we wrote them before, right? We had like g of x. Whatever was in here changed. So it was independent. It's either independent or dependent. That means if it's independent, that whatever is in here, this answer, whatever you're going to get over here, is dependent upon what r is. Okay? So when it, on number 36, where it says, what is the independent variable? You're going to say r. That's your answer for number 36. Again, it's because this answer, whatever I get here, is dependent upon what is r. R changes everything. Just like it did every time I changed absolute value of 4 minus x. Every time I changed it and put something in new for x, it gave me a different answer. This was dependent upon these numbers. They are independent. They are what they are. They're already decided. All right, so that's 36, 38. It says, okay, so we're still using this to solve this problem. Again, you don't have to write this, but they're saying the domain is equal to this. Now I'm just going to write it down for myself. Negative 5, 0, 5, and 10. And so if this is the domain, using this, what is the range? Okay? So let's plug this in again to a t-chart. Alright, I'll look this up. So I'm going to say this is, alright, so here's D, and this is going to be R, and we've got 5, wait a minute, this is the domain. Alright, so again, here's our expression, and here's our domain or our x. So they've given these to us. So I've got negative 5, 0, 5, and 10. So when I plug these in for r, now this I think is just a coincidence that they used an r when I'm looking for the range, but I'm going to plug these in for r, and then that will tell me what my y is. Okay, so if my domain is negative 5, I'll have 5 times negative 5 minus 20. That is going to be negative 25 minus 20, which gives us negative 45. Okay, so there's our first answer. So again, I'm just going to keep plugging in that 0. Anything times 0 is 0. So my answer here will be negative 20. I'm just going to keep these in a row so I can keep track of them. Now I've got 5 times 5 minus 20. That'll be 25 minus 20, which is a positive 5. And I've got 5 times 10 minus 20. That's 50 minus 20 is 30. So for this answer, what we're going to do is we're going to just list the range. Here we're going to say R is equal to fancy squiggly, and we're going to list them least to greatest, which they already are. Least to greatest. And remember, with your negatives, the bigger the negative is, the more debt you're in. So that's why it ends up being the least. Negative 45, negative 20, 5, and 30. Fancy squiggle, and you're done. Alright, that's 38. And last but not least, number 4, D, is, okay, number 40 says find h of 2x. Okay, so again, you don't write this down, but it says find h of 2x. Okay, and this is still under this section where we're using 5r minus 20. Okay? So, what we need to do is throw 2x in for r. So I'm going to say 5 times 2x minus 20. That will be 10x minus 20. That should be our answer. Yeah. So to put it correctly, then we would put h of 2x is equal to 10x minus 20. This is your actual answer. So yeah, so just plug in the 2x. That's all you have to do. There's your correct answer. All right, holler at me if you have any questions. Oh, wait. Yeah, that's right. Okay, bye.